discuss about the average velocity, average speed. Understand? From that, I had some questions also I had to discuss. So in last class, average speed of a car when it travels 200 kilometers in 5 hours. That problem I had to complete. In the same manner, I had observed that when does the average velocity becomes 0? So when does the average velocity, remember this question, when does the average velocity becomes 0? So when does this average velocity become 0 means when the total displacement will be 0, their velocity is also 0. So total displacement be 0, average velocity also 0. When it will come means we have to travel in straight line. So for example, you consider if we go to market and come back to home, that means we have to travel equal distance. For example, you have to travel 1 kilometer or 2 kilometers from your house to market. That means you have to travel in forward direction. That will take us plus 2 kilometers. Again from there you come back. So come back means in opposite direction. So understand this, to travel in this direction. So 2 kilometers, this is the house and this is the market. Again from there, at the same distance will come back. At the same distance will come back in opposite direction. Means it takes as minus 2 kilometers. Then what is the resultant displacement? Plus 2 minus 2 is equal to 0. Therefore, average displacement becomes 0. Then average velocity is also 0. That means when the total displacement becomes 0, then its average velocity also 0. I have to remember that condition. And another one will be, a man used his car. The initial and final odometer readings are given 4,849 and 5,549 respectively. The journey time is taken as 7 hours, 70 hours. Journey time will be taken as 70 hours. Then what is the average speed during the journey? So here I have to calculate the average speed. Understand? So total time will be given as 70 hours. And initial and outing, odometer means what is that? I had observed in vehicles this meter reading when you travel, how much distance will start on round meters will be there in the vehicles. So either bikes or cars are observed. Such a meter, what distance to be traveled to be calculated as odometers, and the speed to be calculated by speedometer. Two will be there, speedometer and odometer. So odometer readings are given here. By considering that odometer readings and total time, we can calculate the average speed of his journey. So average speed is equal to average speed is equal to total distance by time taken. So here total distance is equal to initial reading will be initial reading of odometer will be 4,849. So at that reading you will start. Then ending reading, that is final reading. Final reading means after reaching that point, how much it will be? 5,449. 5,549. Now what is the difference? What is the total distance traveled? Total distance traveled is equal to final reading minus initial reading. Final reading minus initial reading means what do you get? 5,549 minus 4,849. 0, 0. Here 15. 15 means 7. So total he travel distance will be 700 kilometers. What is the time taken? Time taken will be given 70 hours. 70 hours will be given. Then we have to calculate the average speed. So average speed is equal to total distance 700 by 70. 0, 0. 7 ones are 7 tens are. So average speed of the car is only 10 kilometers per hour. It goes very slowly. 10 kilometers per hour only he will be travel. It is a very, very least distance they will be covered. Okay. Then next, instantaneous speed means speed at particular instant. At particular instant, what speed traveled by the vehicle, we have to say as the instantaneous speed. Instantaneous speed means at one particular instant, what speed he will be traveled. For example, to consider he starts from the point A to B, he want to travel certain distance. A to B is the total distance covered. This total distance will be taken as, this distance is taken as S1 and the time taken to reach this distance will be taken as T1. So it is the total time and total distance covered by him. But in this, I have to consider here another point to be considered as C to D. C to D. Another point to be considered, he travelled at the distance of S2 in T2 time. Now another point to be considered, another point here to be considered, S3 to T3 time. What happens? The vehicle does not move constant speed from one point to another point. Remember that. From starting point to ending point, the vehicle does not travel with the same speed. Its speed changes. Its speed will be changes. Gradually, it will be changes. Understand? So, for example, speed breakers or any vehicles on their way it will come. What happens? The vehicle becomes slow. If not, it travels fast. Understand? Like that. What happens? Then their speed up and downs will be there. But on one particular instant, it travels constant. That means, for example, in highways, so there is no speed brakes and they are all vehicles moving with certain ranges. Due to that reason, at that point, it moves on particular instant speed. But in remaining in towns or otherwise in villages, it does not be travel with particular speed. Understand? So what happens? It will be changes. Sometimes if anybody is not on their way, it goes very fast. If any object will come on their way, or any buses or vehicles or speedometers, whatever that, on their way, what happens? Its speed will be decreases. At one particular instant, the speed of that vehicle we have to set to be the instantaneous speed. That speed is called as a instantaneous speed we have to call. Okay, that means average to be considered as here as total. To get the instantaneous speed from this activity to consider as the S3 minus S1 by T3 minus T1. S3 minus S1 by T3 minus T1 to consider to get the instantaneous speed at particular instant, what distance it will be covered, you have to give. Okay. So here all the bodies do not move with the same speed. Just we will be discussing here. So in this case, what happens? Uniform motion and non-uniform motions we have to consider. So first of all, we have to consider the uniform motion. Uniform motion means equal distances covered by a body in equal intervals of time. Equal distances covered by a body in equal intervals of time. So equal distance, equal time will be taken. So it will be travel a certain region. So that will be it moves certain place to another place. Such a motion we call as uniform. So that will be moves in uniform motion. For example, I will consider for that we can represent by graphically time and distance to be taken. So here starting time will be taken as it starts from 0 time. So it is ready to start 0. So here time will be 1 second. It moves 4 meter distance. In meter distance to be taken. 4 meter distance. 2 seconds 8 meters. 3 seconds 12 meters. 4 seconds 16 meters. 5 seconds 20 meters. Like that we consider. For every minute it travels 4 meters distance. Yes or no? 4 meter distance it will be covered. Starts from 0. After 1 second travels 4 meters. Next second, next 4 meters, that is 4 plus 4, 8 meter distance it covers. Then next third second, again for 8, again 4 meters, 12 meters. For 4 second, again 4 meters, that is 16 meters, like that. In equal intervals of time, equal distances it will be covered is said to be the body is in uniform motion. You have to consider. That we have to consider on graph. It is represented graphical representation. It is the distance time graph. What is this called as a distance and time graph? We have to call it distance time graph. So in this we have to consider first scale is important. Scale. Scale means, so in mathematics this what is that? For drawing graphical representations we have to use these scales. So x axis and y axis. First we consider on x axis. So x axis we have to take time. On x axis you consider the time. In this 1 centimeter in graph you have to observe centimeter box will be there. So total for horizontal 16 centimeters, for vertical 26 to 27 centimeter boxes will be there. So observe in graph paper you have to observe these readings. For vertical 27 or 26, for horizontal 16 to 17 boxes you have. So among that, one box is said to be 1 centimeter. 1 centimeter is taken as 1 unit here. 1 centimeter is taken as 1 unit. And on y-axis, on y-axis to consider distance. Distance will be taken on y-axis. In this, 1 centimeter box is taken as 4 units. That means one box to write 4, 8 like that. How it will be there? Like that only we have to consider on y-axis. Remember that the scale is important. How much scale to consider? To plot the graphs, because only there 27 and 17 boxes will be there. So for that we can't draw very lengthy values. Due to that reason we consider these values. 1 centimeter box according to our convenient we can make some units. So in this case 1 centimeter box is taken as 4 units. Now to plot the graph. So to consider one vertical line and one horizontal line on the graph paper. It is an x-axis and it is an y-axis. It is x-axis, y-axis. So this point is said to be the 0. This coordination point will be 0. Next box is taken as 1. Next 2, 3, 4, 5. Further values will be there to be considered. Now here 1 centimeter box, like that box. This distance is 1 centimeter. Okay. So here taken as 4. Next 8. Next 12, next 16, and next 20. So what is this? Distance. So distance will be taken in this, and here you consider as a time. Time on x-axis and distance will be taken as y-axis. Now first point will be 0, 0. So 0, 0 lies at this point. The same point we have to write 0, 0, 0, 0. Next point 1, 4. 1 x-axis, y-axis 4. That means the line will become here. So the line will become here and to give the point. Next 2, 8. 2, 2, 8. So here is the next point. The next 3, 12. So 3, 12. 3, 12. Next 4, 16. 4, 16. Next point 5, 20. 5, 20. So like this you have to represent the points of graph. Now join all these points, you get a straight line which is passing through the origin. Remember that. So to draw the line like this straight line, you get it, which is passing through the origin. So like that here to consider this the 4 and this the equal distances covered in equal intervals of time, equal distances traveled by the body in equal intervals of time. Remember that, like this. This is called as the body is said to be uniform motion. So for plotting the graph, you get a straight line passing through the origin. Okay. So this is about the graph drawn from uniform motion. Then non-uniform motion means distances are unequal, time will be unequal. In unequal intervals of time, unequal distances traveled by a body. Unequal. For example, it will start from 0 to 0. After 1 second, it travels 5 meter distance. After 3 seconds or 2 seconds, it will be 18 meters. Like that, unequal times and unequal distances to be considered. It is said to be the non-uniform motion. What is that called as a non? It is a uniform. That's called as a non-uniform motion. Non-uniform motion. Non-uniform motion. For non-uniform motions to draw the graph, it will be the curve. So you get it with curve passing through the origin. For non-uniform motions to be considered, distances on x and y axis both to be considered. So it will be travel, you get like this curve you will get it. So this is the non-uniform motion. Non-uniform graph you have to consider. It is not travel in equal levels, in equal intervals of time. That is said to be the non-uniform motion. So understand uniform and non-uniform motions. When the bodies will be moved from one distance to another distance in these two ways, uniform and non-uniform motions. Okay. Then next we consider, suppose one of the example will be given, the different positions how the objects will be moved and objects will be accelerated, that will to be considered. But now time is up. Next class we have to continue. Thank you.